So my name is Terence. I'm going to be talking about some of the work that I've been producing in the last few years with generative AI, generative deep learning. And the title of this talk is Artful Intrusions, a hacker's guide to generative AI. And I'll explain what I mean by that in a second. But I thought I'd give a bit of a background to my experience working with generative AI. I've got a very particular sort of story with this. So I started working with generative deep learning in about 2015. I was pursuing a research master's in creative computing at Goldsmiths. And for my research master's, I was working with a generative model called an autoencoder. And I was working with video. I was doing quite dry work with video prediction, but as a way to keep myself entertained, I ended up training this generative AI on all of the frames from the film Blade Runner. And when I remade it, I was like, okay, well, this is very interesting. That ended up becoming the focus of my master's. And after graduating, writing my thesis, I wrote a blog post. I put it online. It went kind of viral on Reddit and Hacker News. And I'd reconstructed the film using this generative AI. And then I put it online, I put it on Vimeo, and within about 4 or 5 days, those videos got taken down by Warner Brothers. They issued a DMCA notice, Digital Millennium Copyright Act notice. But then I hadn't removed the videos, and a journalist from the website Vox had got in touch with me. She thought this was very interesting. She interviewed me. She then asked Warner Brothers for comment, and they freaked out and they put the videos back up. So they rescinded the copyright notice. And then she wrote this article, and this article went massive. I think it maybe had about 2 or 3 million hits. So I overnight sort of became a bit of a viral sensation. And this was the work. So this was the film that I made, Blade Runner, auto-encoded from 2016. So it's a reconstruction of the entire film. After this article went online, I was very lucky. I ended up just getting emails from museums and galleries around the world. So the first place it was exhibited was at the Whitney Museum of American Art in New York. It was also exhibited at the Barbican in London, at Ars Electronica, and quite a few other international venues. And the work's now in a collection of the Geneva's Contemporary Art Collection. So this was the work, this was the reconstruction, but I found the experience of my kind of copyright, falling foul of maybe copyright rules quite stressful. And every time the work was being exhibited, I was very stressed that Warner Brothers, I get an email or a letter from Warner Brothers lawyers. And this was compounded by the fact, so in 2017, there was an academic, a law scholar called Benjamin Sobel, who wrote an article called Artificial Intelligence's Fair Use Crisis. And he talked about the work, and this is the sort of passage where he's talking about the work. And he basically says, from the perspective of copyright law, American copyright law, the work that I produced would be considered a derivative work and would sort of fall foul of this copyright legislation. So, I never got sued by Warner Brothers. I made a very modest sum of money from exhibiting the work and selling the work. So I don't think Warner Brothers were that bothered about this, what I did. And if anything, it probably had helped market their upcoming film, Blade Runner 2049. But this experience was something that I wanted to sort of, if I was going to work again with generative AI, I didn't want to be kind of relying on using someone else's data, using someone else's work to make my own. And so in 2018, I started a PhD again at Goldsmiths. And this PhD was a technical PhD in computer science. But I was really started off with the PhD as this question of how do I train a generative model without imitating data? Or, you can substitute imitating for pastiching, mimicking, parroting, copying data, or stealing data. So stealing other people's work, stealing other people's intellectual property. This has become a very hot topic now, especially with models like Stable Diffusion and Midjourney being huge data sets that have been scraped from the web without the consent of artists and now able to sort of very easily replicate that. But this was in 2018. This was before there was a lot of controversy on the subject. But this is what I was trying to wrap my head around, trying to figure out how to do this. It took me about a year of, I was reading a lot of kind of cognitive science work. I was reading information theory, very sort of deep theoretical work. But ultimately, I kind of came to this realization that what I was trying to do was I was trying to train a generative model without modeling data, which is an oxymoron. It's a complete contradiction, So it took me about a year to really figure this out. But once I did, that was quite helpful. It was quite constructive. It made me rethink the problem, reframe the research I was trying to do. And so then I started thinking, okay, we're not trying to train something from scratch to do something that isn't modeling data. How do we just push or nudge a generative model away from an existing data set? So how do we take something that's already been trained and how do we kind of move it in a direction? And this I ended up, instead of kind of looking at sort of very theoretical, statistics and cognitive science, I ended up just looking at the actual sort of structure of the models and really just thinking about them, their component parts. How can we play around with this? And the talk is kind of a hacker's guide. And I think I started taking a hacker's mentality to working with generative AI, where I was really just sort of trying to pull these things apart, figure out what you can do, figure out the unintended ways that you could use them, figure out ways of using them that you weren't really supposed to do. And I don't think this was a style of working that was well received in sort of like a deep learning community, but there's lots of people, I would say, in, artist practitioners who were sharing a lot of work in social media, in the last sort of 4 or 5 years, who've also been taking this approach. So I'm going to talk about 3 different artworks that I've made over the course of this PhD, using 3 different methods of achieving this thing. So this is going to be the only technical diagram I show. This is the diagram for a GAN, a generative adversarial network. They were sort of first developed in 2014. When I was doing my PhD, 2018, 2019, these were the state of the art. The most famous one, StyleGAN. I don't have actual images from that directly in these slides, but StyleGAN, the deep fakes of people, there's a website, this person does not exist. That's all using a GAN, using StyleGAN. And the way the GAN works is that we have these 2 networks, a generator and a discriminator. When I'm teaching about this, I sort of introduce this as like one person is a forger, that's the generator, and then the discriminator is a detective. So if someone's forging money, trying to make fake banknotes, then the discriminator is the person at the bank trying to figure out, is this real money or is this fake money? And these are extremely effective. So the discriminator is trying to tell what's a real image, say, compared to what's been generated, what's fake. And the generator is got this adversarial opposite objective, which is I want to generate things that trick the discriminator, passed off as being real. In this setup, the generator has one objective, and that objective is I just need to trick this other network. I just need to get my banknotes, passed off as real money, so to speak, or get my images, people of whatever passed off as being real training data. And I had this sort of mad idea, which was, okay, well, what's going on here? What's this discriminator? This discriminator is making these 2 predictions, real and fake, but we never really look at what is fake, what it's predicting is fake. So I was like, well, this, it's very easy. You just invert the loss function, so to speak. It's just 1 minus what it was previously. What happens if we optimize this to making fake images? So I've removed the training set, and here I'm working with pre-trained models. So these 2 models are already trained. For people who have a bit more technical background, I've frozen the weights of the discriminator. And so I'm now optimizing this generator to making fake images. And within about 10 minutes of training, this is what happens. So very quickly, kind of very aggressively moves into this, making these abstract images. But what was quite astonishing is how quickly this would work, using a desktop PC. It takes a month on a supercomputer to train this model, but it takes 10 minutes on a personal computer to do this to it. And I think what's interesting is that we're going from, so on the left is StyleGAN, original model, and we're going from like perfect realism almost, so where people really genuinely can't tell the difference between real pictures. And very quickly we're moving to abstraction. And if we kind of flip this process around, it's a bit like this famous concept of the uncanny valley. So I guess, I don't know if uncanny, there's a direct translation of French, but, so in computer games and in robotics, when we'll be trying to imitate humans, the closer we get to imitation, all of a sudden, when we get quite close, people don't like these images. They find them very uncanny. They find them very stressful and horrible. And essentially, with a deep fake, we're kind of going from almost perfect realism where we can't tell the difference. So we're kind of doing this backwards, hence me sort of flipping this round. So I did lots of different experiments with different models. This is actually from the very first training run I did. It just happened to be the sort of aesthetically most interesting. And midway through this point, we get these images which are just absolutely horrifying. So the funny story is that actually I did this in a day. I showed it to my girlfriend at the time, and I showed her these pictures. I was like, oh, look what I've done, my research. And she just said, that is absolutely horrible. Never show me those pictures again. And I was like, okay, all right. And then I was in my office. I showed it to a colleague of mine, another PhD student, and she had the exact same reaction. She was like, that is horrible. Never show that to me again. And I was like, oh my God, I've done something terrible. And I didn't show anyone for 6 months. I forgot about it. I left it on the drive on my computer. And then 6 months later, I came back to it and I was like, actually, this visceral response is really interesting. So I wrote a paper called Amplifying the Uncanny. I presented it at a conference called XCOAX, Computation, Communication, and X. So just these sort of samples from StyleGAN presented as this grid, I think, it kind of amplifies the sort of the unsettling nature of them. So I'm going to move on now to a different thing. I'm going to move quite quickly. I'm aware of the time. So this was kind of interesting, but you had very little control over the process. And I remember speaking to my supervisor, who's like, I love this work, but I really want to stick my hand in the network and squeeze it and see what happens. And that kind of stuck in my head. And then eventually I was like, okay, this is a very simple diagram, but what if we take a network, we break it apart, and then we insert filters inside the network, filters that you could kind of control deterministically. So give people a way of actually kind of controlling the insides of a neural network during the generative process. So it's probably the most substantial piece of work that I did on my PhD. It took me about a year's worth of work to build it, called the Network Bending Framework. And essentially I built this whole big library where we could take a GAN. So again, style GAN, pull it apart, insert what is essentially Photoshop filters. So I kind of implemented very simple rudimentary filters that would work inside a neural network. Essentially, you can, in any layer of any part of the network, apply it to any what's called a convolutional filter. So there's, hundreds of these in each layer. It's a very complex, we're dealing with very complex black box type networks, manipulate that. So, and this is an example of, applying these filters, different filters in different layers of the network across all the features. And so this was quite interesting as, like starting to take a model that's already been trained, but what can we do to it? Well, how can we sort of mess around with it, push it out, push it into different directions, and again, push it away from just generating the data that's been trained on. And actually, some of the first images that I made using this technique were when I was manually doing this. I was manually before I'd written a whole framework where you could kind of use a config file and, do it in a relatively user-friendly way. Very early on, I was just writing software. I was manually kind of changing the code of the network to do these filters. And so these are some of the most interesting images, I think. So this is where I'm doing quite heavy distortion in the very upper layers or lower layers, depends on your orientation, but the very earliest layers of the network. So where the image is just being formed and kind of messing around with that. So this is a series of works called Teratome. I've got hundreds of these images, but yeah, I think for me, the photographic quality, but also the sort of this kind of lack of formation of structures of the face and stuff. It's quite interesting. So I've made lots of other works with network bending, but I think this is the sort of best illustrative example. And as I said, I think looking at this perspective, like kind of working as like hacking with the network, these were the works where I was doing that process, and that process of hacking, just messing around with the code, seeing what would happen. Kind of led on to sort of further developments, which then sort of became more formalized technical research. So I'm finally going to talk about a more recent work, not using a GAN, using stable diffusion, which thankfully the previous speaker did a good job of explaining. So I don't have to explain that in too much detail. But what's very common now, most people do this, is you take an existing model and you fine tune it. So you take a model that's trained on a huge amount of data, it's taken a huge amount of computational processing to work. And then if you have a smaller data set, you can kind of fine tune it on a smaller data set and it works pretty effectively. And I was doing this, this image has disappeared. Okay, so I was actually doing a freelance project for another artist. It's not something I would normally do, but the art that this guy makes is very different to what I normally do. And I didn't sort of too many misgivings about it. You can't actually see the work, so he can remain anonymous. But I was doing this commercial project. I took Stable Diffusion, which is a big, massive pre-trained model, trained on lots of images on the internet. And then I was customizing it on this artist's own work. This artist make kind of pop arty work with like lobsters. He wanted these like hybrids of lobsters and robots. So spent quite a bit of time on this. But obviously working with Stable Diffusion, you can put any text prompt in. So as I was working on this, it sometimes be quite interesting to put in a celebrity's name and just see what it would produce. Often it would produce like Stephen Hawking, but looking like a lobster or looking like a robot. It was kind of quite curious. And so I worked on this over a period of months. But in one of the last models that I trained for him for this project, I did this again, and it kind of lost the ability to remember most celebrities, most people. But what was funny was when I put in Kate Moss, and all of a sudden it started generating these images. And I thought was quite interesting was that I guess it had sort of remembered the likeness of Kate Moss, but it had forgotten the sort of all the anatomical formation of a human, where there's legs and arms connect, this kind of thing. And I think, the only people this model could really remember how to generate were supermodels. I think it's quite funny. And, these are some of the most photographed people on the planet. And obviously, if you scrape a lot of images from the internet, you're going to get lots of images of these supermodels. So I think it relates to the previous work, but using a very different method, using a very different technique. So this is the most previous work, called it Ghost, and I think it's kind of the ghosts of these people, the ghosts of their likeness that sort of persists in the model. And this was really like a happy accident. It wasn't what I was intending to make. As I said, it was this model. It's a shame that you can't see the image. The image has disappeared from the original training, but the images of lobster robot, cartoonish pop art lobsters look very, very different to this. It was very surprising that these images produced. So this is a Cara Delevingne, again, another very famous supermodel, and David Blandy and Bella Hadid. So this is the most recent work. All of these works have sort of come from sort of tinkering, exploration, hacking. So I'll wrap up now. Thanks for listening.
So actually, I have two questions. Maybe I will ask only for the first one. For the red image that you should not show again. So that kind of image. So my feeling was that if you ask for the fake images, maybe there's many directions that the network can take. I mean, if you reproduce again this experiment, I imagine that you will maybe not get these red images or something different. So did you try to repeat again this experiment to see what happened?
Yeah, so that's a good question. It's very contingent on the sort of checkpoint in training. So, I think a GAN is kind of this endless cycle. There's no kind of defined endpoint. It's sort of a process that can go on forever when you're training a GAN. So it is very contingent on just that particular snapshot, that particular checkpoint. It's kind of at any given point, the generator might be producing slightly lopsided eyes, teeth that are too straight, these kinds of things. So what the discriminator is picking up on is very particular just to that particular moment. And yeah, when you repeat this with different checkpoints, you get completely different results. So yeah, in the paper that I published, there are some examples of that. And I'm actually repeating some of these experiments. I'm probably going to put more of them in my PhD as I'm writing them up. But yes, it's very, very particular. So I think it's not like if you think about this from the sort of technical perspective, there's no kind of global optimum fake image. It's very much contingent on this relationship of those models at that particular time. But yeah, I'd be happy to share more stuff with you later on.
So for the other question you ask, okay, can the network be more, how to make the network not copy the artist? And when I saw this question, I was thinking about the Go game, when AlphaGo did a super program that beat the best players. And to be better than the human, first the program learns with the best player scores, but after it competes with itself, so that the network could be better than the best human. Do you think there's something possible similar for the creativity or creation of art? So the network could be better than the better human artist.
Yeah, I actually wrote a survey paper on the topic of kind of diverging from data. It's another researcher labeled as kind of active divergence, and I wrote a big paper of methods that artists and technical people had developed. But to your point, do you think could an AI build its own training data and get better? Is that your question?
Oh, I don't know if it's by creating its own data, but can become better than human in terms of creativity because some of new way to train or new way to.
Yeah, I don't know. I mean, there was an interesting paper that showed that actually models get worse over time the more and more synthetic data is in their training data sets. And there's a big concern that, with language models, as more and more text written by language models populates the internet, that data that we have is going to degrade over time, and actually models start to collapse and get worse and worse the more of the data exists that's already been generated and synthesized. So I think it's kind of an open question where these things can improve and get better. I think the goalposts are always going to move. So I think with things like Stable Diffusion, all of a sudden we're like, okay, our bar for what we think human creativity is constantly shifting in response to what computers are doing. And I think it's the same with kind of intelligence, whenever we make a breakthrough in AI research, we start to take it for granted and start to think, okay, well, I can't do this. So I think our perceptions of what creativity is and what human creativity is constantly evolving. So yeah, I don't know. Yeah, is the answer.
Thank you.
Yeah.